Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the oblique planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So an oblique plane is a plane which is inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So let us first of all evaluate the order of inclination of this equilateral triangular lamina with respect to the two reference planes. So an equilateral triangular lamina ABC of side 35 mm has its corner A 15 mm above the horizontal plane and 40 mm in front of the vertical plane. That is, this is the corner A of the equilateral triangular lamina that we are talking about. So this corner A happens to be 15 mm above the horizontal plane and this will be 40 mm in front of the vertical plane, and the lamina is inclined to the horizontal plane at an angle of 40 degree. So we have been provided with this information that the first inclination of this lamina happens to be with respect to the horizontal plane, and since this lamina is first of all inclined to the horizontal plane, so initially we are going to assume that this triangular lamina is initially parallel to the horizontal plane, and since this lamina will be parallel to the horizontal plane, so its top view which is obtained on the horizontal plane will reveal its true shape. That is, the true shape will be revealed in the top view which will be drawn below the XY reference line. And another thing we have known by now that it has got one corner A 15 mm above the horizontal plane. So it means that the edge view which will be obtained above the horizontal plane will be located 15 mm above the horizontal plane or the XY line. Then once you draw the true shape in the top view and edge view in the front view, thereafter the second rotation is given to us, that is the top view of the side containing corner A makes an angle of 15 degree with respect to the vertical plane. That is, whatever apparent shape of this lamina will be available, so the top view of one of the sides, you see both these sides they contain corner A, so you can incline either this side or you can incline this side at an angle of 15 degree to the vertical plane. That is, these are the two sides which are containing this particular corner. So either of these two edges we can pick up and we can incline in the third view the apparent length of this particular edge or the apparent length of this particular edge at an angle of 15 degree with respect to VP. Whereas in the second case we are provided with the information that the side containing corner A makes an angle of 15 degree with respect to VP. So here we are not talking about, in this particular case, the apparent length of the plan which is for this particular edge or for this particular edge making an angle of 15 degree to VP. So here we are talking about true length of the side. It can be either this side or this side. That is, true length of the side means that the true length is equal to 35 mm. So this true length of this edge, it makes an angle of 15 degree with respect to VP. That is, this is the angle phi we are talking about. So here, since the top view was given to be inclined with respect to VP at an angle of 15 degree, so this was the angle beta in the first case. Whereas here, angle phi, that is the true length of one of the edges which are passing through corner A, that makes an angle of 15 degree with respect to VP. So true length making an angle of 15 degree with respect to VP means angle phi is given. Now we'll make use of principles of rotation of line method to evaluate angle beta with respect to angle phi. So angle phi is available, true length is available, apparent length is already available in the previous view. So combining this information, we'll be able to work out angle beta. And once angle beta is available, then the projections of the lamina will be evaluated for the second case as well. So let us start drawing the projections over here. So step number 1, you draw the XY line. So as we have discussed that this is the shape of the triangular lamina that we have to draw. So this is 40 millimeter, that the corner A happens to be 40 millimeter in front of the vertical plane, and it happens to be 15 millimeter above the horizontal plane. So accordingly we have to draw this true shape of the equilateral triangular lamina. So we have to leave first of all 40 millimeter distance from the XY line, that is, this is the distance in front of the vertical plane. So let us do the labeling A, B, C. That is, initially we are assuming that this lamina happens to be parallel to the horizontal plane. Reason? Because if the first inclination of this lamina lies with respect to the horizontal plane. So to begin with, we have assumed that this equilateral triangular lamina happens to be parallel to the horizontal plane, and its true shape will be obtained in the top view onto the horizontal plane. So this will be drawn below the XY reference line because HP happens to be rotated clockwise. So here you have, leaving this particular 40 millimeter, you leave this 40 millimeter and draw the equilateral triangle. So just see, after leaving 40 millimeter from the XY reference line, now you draw the equilateral triangle. So since the triangle is equilateral, so the internal angles, all the three will be equal, and they will be equal to 60 degree apiece. Now having drawn the top view of this lamina, now we need to draw the front view. In order to draw the front view, the projectors through A and B and C will be drawn, and the front view, that is the edge view of the lamina, will be drawn 15 millimeter above the horizontal plane, because we have been provided with this data that it has got its corner A 15 millimeter above the horizontal plane. So here we go. Now two projector lines we have drawn. So 15 millimeter above the XY reference line, we are able to locate the edge view for this particular lamina. Now why this view is edge view? Because the lamina happens to be perpendicular to the vertical plane initially. So since this lamina happens to be perpendicular to the vertical plane, so its projection onto the vertical plane in the form of front view will provide us the front view of the lamina. So this is A dash corresponding to A, and then through this you get B dash and C dash. So now we are going to measure this edge length over here, and for all practical purposes, corner A will be resting always in all the three situations 15 millimeter above the XY line. Similarly, this corner A will be resting in front of VP by 40 millimeter. So one locus line we have to draw over here up to 15 millimeter. Similarly, for point A, we have to draw another locus line. That point A will always rest on the locus line, which will be 40 millimeter in front of the vertical plane. So just see, one locus line we have drawn over here. Now the first inclination of this lamina is with respect to the horizontal plane, and this angle of inclination is provided to us as 40 degree. So this angle is 40 degree. So now the third view, the first view was the true shape, the second view is the edge view, now the third view is rotation or the translation of the edge view. Now whatever edge view has been obtained, so we'll measure this distance and transfer this distance at an angle of 40 degree with respect to the XY line or with respect to the horizontal plane. So this distance we are going to measure, and this distance has been transferred over here. So the new points in elevation, they are A1 dash, B1 dash and C1 dash. So this distance is equal to this distance over here. So the edge view has only been rotated, no change has been made. Now you drop the perpendicular projections through A1 dash and B1 dash and C1 dash. Similarly, you draw the horizontal projectors through the plan view which was obtained previously, that is points A, B and C. Now we are going to measure the corresponding points. So wherever these two points they intersect, you see A1 dash, you get the vertical projector line over here. Through A you get the horizontal projector line. Wherever these two intersect, you get the position of point A1. Similarly B1 dash, this is the vertical projector, and then this is the point B. Horizontal projector you draw, wherever these two intersect, you get the location of point B1. Similarly point C1 dash, you draw the vertical projector through C1 dash, and then wherever it intersects with the horizontal projector through C, you get the location of the point C1. Now into this new figure you can observe that this is an apparent shape of the equilateral triangle. Why? Because the edge view of this equilateral triangular lamina happens to be inclined with respect to HP. So the dimensions, please see, A1 C1 is foreshortened or reduced. Similarly the dimension A1 B1 is also foreshortened or reduced, but there is no impact on this dimension B1 C1. Why? Because this dimension is still parallel to the horizontal plane. So the edge B1 C1, that is BC edge of the triangle, it is still parallel to the horizontal plane. So this is still the true length. So here we obtain apparent length for B1 C1. We have obtained apparent length for the edge A1 C1. So both of these edges, they have been reduced. So this is the true shape of the triangular lamina. This is the apparent shape of the equilateral triangular lamina. Now in step 2, this is also apparent length, this is also apparent length. Now we have been provided with this information that the top view of the side containing corner A makes an angle of 15 degree with respect to the vertical plane. It means that since we are talking about top view of the side containing corner A, so we are talking about the apparent length of the edge of the triangle which is containing corner A. So both of these edges, they are containing corner A. So it is your sweet will. If you want to pick up this edge, you can pick up this edge to be inclined at an angle of 15 degree with respect to VP. If you want that I want to take this particular edge to be inclined with respect to VP, so you can do it. So let us now transfer this particular triangular lamina at an angle of 15 degrees. So we have chosen this edge, A1, B1 we have chosen. So this point will be A2. So I'll measure this length A2 and B2, that is A1, B1 length I am going to measure. So this length will be projected and marked over here. So after you mark this length A2, B2 equal to A1, B1, now you have to transfer this triangle. How this can be done? It's very easy. You keep your compass needle over here, open compass equal to A1, C1. So open compass equal to A1, C1, mark an arc. Similarly, keep the needle of the compass here, open compass this much. Again, keeping needle of the compass here, mark another arc. So wherever these two arcs they intersect, that will give you point C2. Or another way, you drop a perpendicular from C1 onto A1, B1. Second method of transferring this triangle, from C1 you drop a perpendicular onto A1, B1. Now you measure this distance. Please see, you measure this distance, mark it over here, and from here you measure the perpendicular distance over here. So either way around, even using rectilinear distances also, this figure can be transferred, or by simply marking two arcs, you can transfer this figure into the new view. So step number 1 was the true shape. Step number 2 was the edge view. Step number 3 was the rotation or translation of the edge view. Step number 4 is the corresponding view. Step number 5 is again the rotation or translation of the plan projection view. Now we have been able to obtain the top view of this oblique lamina. Now from this we want to draw the sixth view, which is going to be again corresponding view. So now projectors through A2, B2 and C2. So the vertical projectors will be drawn upwards and the horizontal projectors from the previous view will be drawn forward. So please see, we have drawn the vertical projectors through A2, B2 and C2, and similarly the horizontal projectors through A1 dash and similarly B1 dash and C1 dash, they have been drawn. And let us work out the corresponding points. So this is A2 vertical projector, this is horizontal projector through A1 dash. So we obtain the point A2 dash over here. Similarly, B2 vertical projector comes through this, and here you have the locus line for the horizontal projector through B1 dash. So the point B2 dash is located. Similarly, the third point, the vertical projector through C2 is drawn, and let it intersect with the horizontal projector which is coming through the point C1 dash. So having obtained these 3 points, now I can join all of them. So this is the apparent shape of the lamina in the front view. This is the apparent shape of the lamina which is obtained in the top view. So the first part of this problem has been completed. Now let us start with the second part. So both the apparent shapes, that is front view and top view of the oblique lamina, have been obtained when the apparent length of the side containing corner A was making an angle of 15 degree with the VP. Now the situation has changed now, because in the second preposition we have been provided with the information that it's not the apparent length of the edge, it is the original side, original edge of the triangle which is measuring equal to 35 millimeter. So this edge, true length, makes an angle of 15 degree with the vertical plane. That is, this angle is equal to phi, this angle is not equal to beta. So now we will make use of the principles of the rotation of the line, because we know that in any view you draw two locus lines, and these two locus lines will contain both the true length and they will also contain the apparent length. So over here you see I have got the information about the true length. So the starting point of the true length I know, you see I have marked this point as A3. So A2 has been transferred over here as A3 over here. Then I have known that angle phi is equal to 15 degree. But angle phi is with respect to the true length of the lamina, true length of the edge of the lamina which is containing corner A. Just see, true length of the edge of the lamina which is containing corner A is equal to 35 millimeter. So what I am going to do, since angle phi is given, so angle phi is corresponding to this true length, blue line. So just see, if this name is A3, so this name will be B31, because there is always a suffix in the case of a true length. So I am going to label this as B31. So A3 is the first initial point, which is this one. This is B31. So I want to work out this particular apparent length, and this apparent length is already available with me over here, because I have already told you in the previous discussion that when this projections are to be obtained, so it is this figure which is to be transferred. So in order to transfer this figure, I need to find the location of this apparent length onto this particular projection plane. So just see, from here I have already drawn the true length. I also know the value of my apparent length, that is A3 B3 is known to me. So what is the value of A3 B3? The value of A3 B3 is equal to the A1 B1, or it is also equal to A2 B2. It is equal to A2 B2, or it is equal to A1 B1. So I'll put my compass over here, needle, and open the arc which is equal to A1 B1, which happens to be the apparent length of the edge of the equilateral triangle which is passing through the corner A. So through A3 I have already measured this distance, and I'll be marking it over here onto the same locus line. So between the same locus lines, my true length and my apparent length will be lying. So since I know my apparent length, so I have been able to transfer this apparent length over here. So having transferred this apparent length, I am going to mark this point as point B3. So if this is A3, this is B3. This was A3, true length was B31. So first of all, again I'll repeat, just see, initially I have drawn the true length at an angle of phi is equal to 15 degree. Now having drawn this, I will be drawing the locus line. So I know that between these two locus lines, that is over here, you can check, between these two locus lines, my true length and my apparent length, they will be lying, and starting point will always remain the same. So keeping starting point the same, I know the measure of my apparent length, so I'll be transferring this apparent length onto this particular locus line. So I obtain the point B3. So A3 is obtained, B3 is obtained. The moment you put down B3 over here, then you need to measure this angle of this apparent length. So apparent length angle, we have already discussed that apparent angles, they are always greater than the true angles. True lengths, they are always greater than the apparent length. So you check, true length of the edge is 35 and apparent length of the edge is smaller. Similarly, the apparent angle is equal to 17 degree and true angle is equal to 15 degree. So beta is greater than phi. So this angle will work out to be slightly higher than the true angle. Now having obtained this A3, B3, so once again A3 is obtained, B3 is obtained. Now you can mark two arcs over here, arc corresponding to A1, C1 and arc corresponding to B1, C1 from here. So A1, C1 arc you can start from A3 and B1, C1 arc you can start through B1, that is B3. So two arcs we will draw and we will be able to transfer this apparent shape of the equilateral triangle onto this particular view. So here we have been able to obtain the top view of the lamina, in which the first angle of the lamina was made with respect to horizontal plane at an angle of 40 degree, and the second angle of the true length, that is angle phi, was given to us as 15 degree. So from that phi angle we have been able to work out beta angle, and after evaluating beta angle, now this plan projection view, this will be shifted over here, and after shifting this plan projection view from the previous iteration, now step number 5, first part has been completed. Now in the second part, once again the corresponding view will be obtained. So as we have done over here, 3 vertical projectors through A3, B3 and C3 will be drawn. Just see, 3 vertical projectors will be drawn, and similarly the horizontal projectors through A2 dash, B2 dash and C2 dash have been drawn. So wherever the corresponding points of intersections are there, we are going to work them out. So please check this out. This is A3. As it intersects with the horizontal projector from A2 dash, you obtain the point A3 dash. This is B3. This is the vertical projector. Wherever it intersects with the horizontal projector from B2 dash, you obtain the point B3. Similarly, here you have C3. So C3 and C3 dash, they will fall in one vertical line. We have taken one vertical projector, and wherever it intersects with the projector of C2 dash, we obtain the point C3 dash. So you can see, because of this change in inclination, so minor change in shape has been obtained. So this proves that if the angle of inclinations, they are changing, so it will have the impact upon the apparent shapes which will be visible in any given view. So here we have also witnessed one more thing. If the angle of inclination was less, slightly better view was obtained, that is slightly larger view was obtained. If the angle of inclination has been increased, so slightly leaner or thinner view has been obtained over here. So with this discussion, we have been able to evaluate how to draw the front view and the top view projections of the lamina when the lamina happens to be inclined to both the horizontal plane as well as the vertical plane. So I hope you have understood how to draw the procedures for working out the front view and the top view projections of the oblique laminas. So we'll be continuing with this discussion in the next lecture as well. So thank you very much. Thanks a lot. Thank you.